Today we're going to talk about buoyancy. Why do some things float and other things sink? Everyone knows that a rock will sink while a cork will float.
You might think it is simply the weight of the object, but further examination shows that that can't be the only factor, as incredibly heavy objects, such as a cargo ship, are still able to float. The key to buoyancy lies in density, which is the mass, how heavy an object is, divided by the volume, how much space an object takes up. Or stated mathematically, density equals mass divided by volume. Let me illustrate all of this with a story. In the 3rd century BC, the king of Syracuse suspected that his goldsmith was stealing from him. The king wore a crown that was supposedly pure gold, but he thought that the goldsmith might be using a gold-silver alloy instead and keeping some of the gold for himself. The king tasked Archimedes, the great mathematician and philosopher, with determining if the crown was pure gold. Archimedes understood volume and density and knew that if the crown wasn't pure gold, it would have a larger volume than pure gold of the same weight. But he didn't know how to find the volume of an object without changing it into a known shape such as a cube, and he wasn't allowed to destroy the crown. While contemplating this problem, Archimedes went to the public baths, where he observed that the water level rose when he entered the tub. He realized this principle could be the solution, and purportedly leapt up and ran naked through the street, shouting, "Eureka! Eureka!" He noticed that the water displaced by an object is equal to an object's volume, and then used this to show that the crown wasn't actually pure gold. After this discovery, Archimedes went on to discover much of how buoyancy works and formulated what is now known as Archimedes' principle. An object partially or wholly immersed in a fluid is buoyed up by a force equal to the weight of the fluid displaced by the object. The practical application of this is that objects more dense than water, like a rock, will sink. Objects less dense than water, like cork, will float, and objects of the same density as water will remain at the same level and neither sink nor float. Think of it this way. Weight is a downward force, and buoyancy is an upward force. If the two forces are balanced, the object would hover. If not, it will either sink or float. If an object weighs more than the weight of the water it will displace, it will sink. If the object weighs less, it will float. This is why a heavy ship can float, while a small object, like a brick, will sink quickly. The size of the object isn't the only thing that's important. It's the relationship between the weight of the object compared to the weight of the water the object displaces. Buoyancy has many applications. It is important when designing boats to make sure they float. With submarines, they need to design ways to make them sink and then be able to bring them back to the surface. Life preservers are designed with buoyancy in mind. Scuba divers have to know how to float, hover, and sink, and have to wear weights to help them. You may wonder how a ship carrying a heavy load can float, when the load itself would sink if it were dumped overboard.
Let's try an experiment. Here I have a ball of clay. If I drop it in the water, it will sink immediately. Now if I take the same ball and flatten it out and turn it into a boat, it will float. Okay, I think that's good.
It must make room for its own volume by pushing aside, or displacing, an equivalent volume of liquid. The object is exerting a downward force on the water, and the water is exerting an upward force on the object. Of course, the weight of the object also factors in. The solid body floats when it has displaced just enough water to equal its own original weight. You might think of buoyancy as the loss of weight an object seems to experience when placed in a liquid as compared to its weight of air. Now some things can be even less dense than air, but we'll save that for another lesson.